Assalamualaikum warahmatullahi wabarakatuh, and peace be upon you, to the fellows and the daughter. So, for this topic, for today, the role of cooking in the preparation of calculus materials, from subject, surface aesthetic and machining component by group 2. I will continue my slide now. Thank you. So, for this second slide, I will introduce you my members group. So the little woman is Siti Aisyiah. He is lead of this group, and the second member Danish, and the third is Syafierul Akiemie. Is me.
It's me.
So I will continue for this topic. For introduction, the role of coating in the preparation of calculus material. The hollow metal spread represent the interesting substance suitable for the calculus material production by the powder metallurgical method. Thin wall and the two stronger hollow particle are of the interest for less extremely lightweight but mechanical stronger components. The basic material properties improving by the coating disposition is described. The electricity and electroless coating of iron hollow space with Cu and Ni influenced by bed arrangement is demonstrated here. The influence of the deposition method and the coating condition are in the mechanical properties, surface morphology, and coating composite of the cover spray where investigates. The effect of carrying intensity was also studied here. It was found that the call structure morphology, and composition and mechanical properties of prepared sample are strongly affected by the coating method. So, produce material like metal foam, metal like spun or complex said product play important role in many industry application, which is innovation or innovative. A hollow metal spray is used for the production of highly porous metal structures by powder metallurgical method. Metal coating can use to improve mechanical properties, surface morphology, and wear corrosion resistant basic material. On of the way how to produce the calculus solid constant in the structuring of the component made of hollow metallic practice the property and mechanical behavior of the final product strongly depend on the properties of the original hollow metallic particles and also on the structure of the cell. Therefore, the preparation of reliability how hollow metallic properties of defined parameters represent an important step within the calculus solid production by means of the powder metallurgical route. The modification of the mechanical uh, characteristic of hollow sprays by coating of an alternative method of changing their properties and structure, requiring relative inexpensive equipment. So the aim of the present work was to study the copper-nickel coating of porous hollow iron particles. The coating disposition were studied binary Nu and Cu alloy obtained by electrodisposition. So at first Cu disposing during the chemisation and after was film obtained by the electrodisposition.
Assalamualaikum. I will continue this slide. Schematic representation of the electrolytic cell use. Base projection of the cathodic compartment 1. Cathode 2. Anode 3. Cathodic compartment 4. Diagram 5. Anodic compartment 6. Glass propeller. Magnetic stirrer. Diameter of the cathodic compartment. Width of the cathode. Morphology of hollow particles. Experimental. Porous spherical founder produced from oxide iron is obtained in pickling acid recovered in wire mill with the following fluidized bed line. This oxide reduced in following hydrogen for 6 hours at 850 Celsius to produce similar spherical iron powder. After screening, the fraction between 0.63 to 0.71 mm used there. Electrolytic cell with separated cathodic compartment was used for electrodeposition. Square the cathodic is formed by a cylindrical container. Window with a diagram allowing electrolytic diffusion and prevents particles from contacting the anode. Place appropriately into the vessel. Steel cathode, stainless steel and nickel or copper sheet anodes used. The suspension was held in place fluid by steering the current intensive circle facial area as a result of shock contact which frequently, repeatedly for hollow sapphires with cathode solid during electrolysis. An extensive contribution surface of hollow particles around the electrode to solid electrode surface. The current intensity is more exactly from the current density. Both estimate specific surface for hollow particles which use determined by the bed method. This method is not very suitable for such particles large and therefore this value is flawed. Galvanostatic electrolysis. The rate of the stirring was 1800 minutes. The electrolyte containing 1.42 m and 0.4 m H3BO3 was used as a nickel plating bath. The electrolyte used as nickel copper plating bath was an acid. The composition of electrolyte used for copper deposition was 1 mcu S04 and 0.1 m H2S04. The electrolytic coating process was run galvanostatic alive from 30 minutes, 2.5 grams of pea powder and 200 of elixir. Electrolytic coating with copper was done by pouring the pea powder into solution. Experimental. Fig 3. The influence of current intensity on metal content for difference coating deposition wave. The influence of current intensity on the amount of Ni and Cu in the coat of the powder particles is shown in Fig 3 for different original procedures. Need to be stated that the amount of each metal is Figure 3 refer to an electrolysis time of 30 minutes with bar exception. In this case, the total amount of Ni and the amount of Cu refers to the same electrolysis time. The first group of bars denoted as Ni2 represent the result obtained from electrodeposition of binary Ni2 coatings. Improvement current intensity in favor of Ni deposition and suppress Chu deposition in the double coating component. Chu content is always higher of Ni content. Position of binary coating code Ni2 is possible by using agent complexing synthesis. Experimental. Surface of Phi particles covered with Ni2 coating binaries are shown in figure 4. This micrographic suggesting a uniform distribution and compact morphology of the film. Phi particles are very coarse and porous, and therefore they are very large surface. Coating thickness binaries are consequently small but still coated particles strong. After deposition, the process is less rough and porous, but not significantly altered. Film thickness and hence surface smoothing increase with higher current intensity. Approximated average thickness Fe. Particle wall is about 130 um and film thickness Ni2 is about 10 to 20 Table 1. Particle cavity expands non-uniformly due to the replacement of Fe by Cu. Average statement, the particles where thickness is about 100 and varies from place to place, and thickness, the double layer is about 10 to 20 as well. By this way, the coat particles are mechanically strong. Table 1 summarizes the particle current efficiency values for current intensity and electrodeposition path, which difference in general. The efficiency of electricity decreases with increasing current intensity. Already found in a previous study that efficiency during the plating process of deep range powder particles optimal condition between 35% and 33%.
Okay, now I will continue this presentation. Experimental figure 5 is photograph of a sample made from Cu electroposition and sequence in electroposition. The morphology of surface changes fundamental. Is it denser and smooth? Higher solidation with thin-walled hollow particles with cavity large is interesting from the point of view of material production circular. Because of that copper disposition without current on iron hollow particles has been investigated. Second, during electrolysis deposition, particles are found iron dissolved from this inside and the copper layer deposit out from outside. Hence, the cavity inside the particles have been enlarged and the particles wall have been thinner. Electric position result in ni film on particles powder following electrolysis copper disposition shown in the last group of bars in figure 3 marked in generally position of ni metal less noble favored in increased intensity current. About 45 of Cu and 5 of Fe already found a large amount of copper and deposit of Fe particular complete displacement of Fe by Cu possible. From the last figure, morphology of Se hollow particles covered by Cu by sedimentation and next with Ni by electrodeposition detailed SEM. Copper layers and metal are porous allow diffusion Fe ions from CuFe interface into the solution, figure 6. The iron particles almost completely dissolve in the current sedimentation and before the final product consists mainly of copper. It found that its substitution complete as Fe by Cu take in the place. The Cu particles are very crunchy and destroyed. The same thing happens if cementing takes place quickly. The optimal condition is 180 to 200 minute, 30 30 degrees Celsius, 30 gram Fe, and 600 cm3 of electrolyte. In the case, the typical content of Cu is 95%. It septically hollow with large cavity and thin walls, and the core is densest. Particles are quick, weak, and difficultly operate. It was found an effect of Ni plating is resulting in significant concentration of powder particles. Figure 6 shows the surface Fe particles covered by Cu by deformation without electrode and so on with deposit and eye layer. The surface is very raw and porous in contrast to the way coating is deposit others. The roughness structure is quite different because the rapid deformation of copper is thick deposit. Even the disorder, tetric morphology, the coating layer from the particle walls is average thickness about 60 50 m. Okay, as the conclusion, circular material of ascertain potential for the production of lightweight component through the powder metallurgy. A hollow iron separate is the material which is subtable for the preparation of circular material regular structure. The nature of original hollow particle is modified with the used nickel coating metal with copper. Cavity in Fe particle and Fe particles wall size of same. The coating layer is thin and follow the surface roughness. Increase current instinct support in Ni deposition and blocking deposition in Cu into component coating. Both metal content increase with increasing current elasticity for individuals. U layer electroposition and then Ni. Electroless copper deposition are preceded by low current intensity at the beginning. Electric Cu content in coating disposition is always more than higher the Ni content. The main advantage and difference of deposition current-less copper is a replacement of the Fe by Cu and sequence enlargement of the cavity regular at the particles and narrowing of particles walls.
Thank you so much for your attention, for listening our presentation, and I hope you guys enjoy so much. And from our group, want to say really sorry if any mistaken we do it during this presentation. So the important, don't forget to like and suprema sarima subscribe. Thank you so much and see you soon. Bye. Assalamualaikum.